I don't know.
I don't get it. Why ah? Why ah?
Okay, the whole paper was bad, I remember.
Then do you want me to print the paper for you now? November 2022, there's only paper 1 and paper 2 only. There's no like paper 3. Bad enough already lah. It's not like you all can finish it also. Question 4. Start with question 4. You want me to print both papers? Who else needs me to print? Calling once, twice. It's intermittent. I don't know what the heck they have so much to drill for. Both papers? Or do you have the paper 2 at home? No, I'll be going through paper 2 anyway today. Say what?
Both at home.
Both at home.
Yes.
Then your calculator got bring or not?
Yes,
Your brain got bring or not?
I hope so.
Actually, I don't know. We'll see. You want me to screw up? Which ones?
No need. I thought I was another.
Wow, worse.
So there was one big projectile watching the screen. I got wrong. I wanted the paper.
I don't know which one you're talking about.
I'll send it.
Yeah, send it. That's good. Hello. Jace, when are you getting a paper back? Where is it?
Oh, I got only half the paper.
Oh, paper 1 or half the paper. They tore the paper 2 and half.
I changed. I get some
Paper 1 was what? What's the score for paper 1?
publics.
Paper 1 is a problem, right? Okay. That's why the signboard is like that lah. Come. Well, who's that? Who's texting? Wow, fast game. Okay. We gotta have to start with 4 first. Right? We gotta start with 4 first. But I'll tell you this, okay? Just take note that sometimes this kind of like kinematic questions, right? They tend to jump scare you, right? You understand? Right? So this is the one of them. Okay. So if you realize that this is something that is beyond you for the moment, then just leave it alone and just go on to the next one. All right? Because this is really one of the you got to learn how to do you got to learn how to strategize. Right? Strategy is one of the key things in I mean not just in paper, in life as well. Right? There's some things that are beyond your control. Don't try to control it. Right? Just let it go. Try to do all the things that you can do. So this is one of those questions where if you have to let go, then you let go, because the calculations for this is a little bit many steps. Huh? No kick ah? Can ah? Oh, you did it. No kick. Okay, can. All right, but for those who are not very familiar with this, then you have to kind of like learn how to do it firstly, and then learn how to do it fast. Okay, so right, I'm going through this. Like, reminder again, this is not meant for you to know how to overnight how to figure out how to do this kind of questions, right? There's quite a few steps to this. Number one, in order to meet same distance above the ground, in order to meet here, do they have to meet at the same time? They have to meet at the same time. That means in order to meet, they must be at the same place at the same time. Am I right? Same place, same time. Can? Okay, same place, same time, huh? Right. So which means that for object one, right, ball one, okay, it needs to have fallen a certain distance, and ball two must have risen a certain distance. Okay, I'm going to call this distance y. Right? Yeah, so sometimes you have to resort to doing this, right? I did this yesterday from scratch, right? Because yesterday I think pretty much was the second time I did this question in the last few years. Because it's November 22 paper, right? November 22 means I only did it once last year for last year's batch, and then I'm doing this the second time only myself, right? So yesterday was after 1 year of not doing it. So how do you do this? Write down the equation for ball one and ball two. What's the equation for ball one? And what equation would you write? It's something to do with speed. It's something to do with height. It's something to do with time. Which equation do you think you should write? V equals U plus AT. Yeah, so S equals to UT plus RVT. What the? Okay, so S equals to UT plus RVT. So the base equation is S equals to UT plus half AT squared. So then you know this is IB style, which means that you have to write one equation for one object, write another equation for the other object, right? For the first scenario and for the second scenario. What's the first equation to write for object one, ball one? So you have to write S equals to UT plus half AT squared, right? But the U is what? 0. So you drop from rest, right? So, but what's S specifically? So let's say we use whatever we have defined in this scenario. What's S then? For ball one, H minus Y. For ball one, H minus Y. Okay? Equals to 0 plus half GT squared. Then we have another problem. Okay, we have another problem. So you know that when you're dealing with one object projectile motion, right, the initial direction is a positive direction. Right? You know that there's a positive. But down here we got two objects, and one is falling down, one is going up. So which one do you want to be the positive direction then? You want up to be positive. If up is, no, it doesn't matter. It doesn't matter. It really doesn't matter. So if you want up to be positive, then you need to change these values here to negative. So then if you want this to be downwards to be positive, then you have to write all the equations for ball 2 in negative. Fine? Okay, good. So for ball 2 now, right? Ball 2, another color equation, right? Ball 2, what is the displacement of ball 2 at that time t? Negative y. All right, let that sit in for a bit. Because she chose already. She's the one who chose it. She chose downwards to be positive. That's fine. Right? So she chose it. Right? I mean, yesterday also I did the same thing. So that's the tough part. Trying to make sure that the convention, the negative convention, is universal for both objects. That's the tough part. Okay? Negative y. Katie?
Yeah.
From the baseline here, negative y. Okay? Right, negative y. Then, who did I send yesterday? Got one question is t minus t1. Big T minus small t. I sent it in group chat, that one. Oh, that's not a question. But that one's also projectile motion, right? That one? That one also. That one? Oh, no, that one is Ethan sent one. Okay. Anyway, so, okay or not? This one, minus negative y. Then right now, equals to, is the initial speed of object 2 0? No, right? It's u, right? They say u, right? Okay, then we go with u. U t plus half just g only.
Why?
Because downward is positive. So in fact, this one, the u is negative. Negative u. So this question is no matter which one you choose to be negative or positive, right? You're in trouble one. You choose downwards to be positive, this one okay, the other one not okay. You choose upwards to be positive, this one okay, this one okay. Then you just have to live with it. Right? You just have to deal with it. Just deal with it. Can? Okay not? Like you're one step closer to the answer already. How? Just sub in minus one. Just sub this in. And you can get your answer already. Yeah, so what's the physics part of this? This equation, no? The physics part of this is coming up with the equation for two of them, and then the rest is just the math. The math of you subbing one into the other. But like I said again, this is a jump scare question. At the start, it's meant to make you lose composure. If you get affected, if you get emotionally affected by these kind of questions at the start, and you decide that that's it, like exam is not a good thing for me, then you are basically losing out in the race in the game lah, because you let your emotions overcome you, right? So is it mental health? No, it's called mental resilience. I'm an advocate of mental health, but I'm a bigger advocate of mental resilience. Don't let the small things get to you, because these are small, tiny, little, annoying little bugs. They're just bugs. What do you do with bugs? You spray them, or you smack them. Do you know how to kill flies? Have you tried killing a fly before? How do you kill flies? Right? You use a rubber band, you stretch it, and you let go at it. Right? Because the fly can't fly faster than a rubber band. That's how you kill flies. Just squash the bugs as they come along. It's okay, just squash them. Yeah. Can. But it's okay. I mean, but whatever it is, right? Don't let these things get to you emotionally. Right? It's meant to jump scare you. It's meant to make you lose your composure. That's what the exams are for. They're testing your resilience. Number 4 done. Next one, number 5. Request on number 5. You know what's annoying about this question now? Look at the picture. Look at the picture. Right? I'm doing 2022. Not 2020. Yeah. 2022. I gave the instructions in the group chat, right? 2020 first, then the 2022 first, then 2020, right? Isn't it? Yeah, okay. So 2022, this one here. Look at the picture. What do you think the picture shows you? Like if you look at the picture, does it look like a symmetrical shape? You would think that there's no air resistance, right? By looking at the picture. But in the words in here, it does say that there's air resistance. That's the annoying part. There's air resistance. So in fact, the trajectory of the thing will be like this. But why did it draw it like that? I don't know why. I think they're just trying to trick you only.
Symmetrical, right? But they never said air resistance X on it.
You have to infer that if they give you a path that's not symmetrical, you have to, like the other question that we did recently in the last week or something like that. They gave you a path that's non-symmetrical, right? But the question never say anything. You have to infer that it has air resistance. Now you have to read the question and understand that there's air resistance and not infer that there's no air resistance, right? Then you might be complaining, why they go show me this, this symmetrical path? Too bad. That's what they say in the question. Air resistance acts on it, right? Okay, so if air resistance acts on it, right? This is the object. Where's the drag? Where does the drag act? At that point there. Where's the direction of drag? Right? Diagonally downwards. Right? Diagonally down to the left. Right? Like this. This is where the drag is acting. Correct or not? Right? So if the drag is acting this way at the diagonal like this, right? Does it have two components? Yeah? It has two components, right? What are the two components? Right? You have your horizontal component and you have a vertical component. Right? So this is like drag X. And this is like drag Y. Okay? Draggy. Right? So drag Y is pointing down. Then on top of that, you have the weight. If let's say you have the weight of the object, right, which is this one here, this is the weight of the object. So what will happen to the total resultant force of the object when there's a presence of air resistance? What will happen to the vertical total resultant force? It'll be more than mg, more than weight. If there's drag, if there's no drag, what are the forces acting on it? Projectile motion as it goes. If there's no drag, okay, as it goes like this, no drag, no air resistance. What's the only force that acts on the ball? Right? G is not a force. Mg, right? So only the weight, right? Okay. So what will be the resultant acceleration of this ball? What's the acceleration of this ball? How much? What's the acceleration of this ball? Yeah, 9.81. 9.81 meters per second squared downwards. Right? That's the acceleration of this ball. But now that there's air resistance, there's drag on top of the weight. What will be the acceleration of this ball? What's that? More than 9.1. Yeah, you're right. More than 9.1. So I don't know how much, but it will be more than 9.1 meters per second squared. Right? Yes. V is not a force. V is not a force. V is just a velocity. I'm asking you about forces. V is not a force.
Yeah,
Yes, yes. Then?
I'm saying like me not having a horizontal and vertical component, or you can just like
No, V has a horizontal and vertical component, but it's not a force. What does force lead to? Yeah, I know you get it, but what does force lead to? Force leads to acceleration. What does acceleration does? What does acceleration do? It causes the V to change. Right? So the V has vertical and horizontal component, but it's changing as this object goes up to it, right? But it's changing because of the forces, right? So what a lot of students would tend to say is that, oh, isn't the V like, acting against the drag? They will say things like this, oh, the V is acting against the drag. That's wrong, because you're saying velocity is acting against a force. That doesn't make any sense at all, right? The V is not acting against anything. The forces that's acting on the object is only the drag and the weight, which causes the V to change. Okay, so yes, right? V has upwards and horizontal component. So at that point, the vertical component of the acceleration will be greater than 9.81, right? And the horizontal component of the acceleration, horizontal, will be non-zero because of the drag that's pointing in the x direction. So B is your answer here. Yes? Here, at this point, the data is always changing. It won't be the same data as the one you initially launched at. Yeah, it'll be at that point, at the moment, at that point in time. There is no such question. There is no such question where they ask you to find the range or the maximum height when air resistance is involved. The best that they can do is to ask you that at that point, what is the resultant force acting on it? At that point, what is the acceleration acting on it? At that point, what's the velocity acting on it? But there is absolutely no way, never ever been asked before, where they give you air resistance and they ask you to find, oh, what's the range of the projectile motion when there's air resistance. When there's air resistance, it's not called projectile motion anymore, right? When there's air resistance, it's called asymmetrical, right? Non-symmetrical motion, right? So that will be when there's air resistance. There's no such question that's ever been asked before. That's what you're thinking of, right? They will never ever give you air resistance and ask you what's the final range of it, or what's the final height, or what's the final velocity. They can only at best ask you at that point, right? What's the resultant force? What's the acceleration? Okay, that's for number 5. What's the next one? 10. Anybody needs 8? You need 8, Yeah, because common mistakes, right? So that's the thing, right? Everyone will all align into some point, right? At some point, everyone's answer, mistakes will all be the same, right? Which is good. Why? You want to have a unique problem. You want to be unique in such a way that even the questions that you don't know how to do you want to be different from others. No, why would you want that? That's a very strange concept. All right. Okay. What's the power of the engine? What's the engine doing? What's the engine doing? This is driving force, right? Driving force. Why is the car not accelerating? Is it accelerating or not accelerating? Yeah, the question says constant velocity. So why is it at constant velocity? Why is there no resultant force? There is a resistive force acting on it, which is how much? Which is how much? Yeah, which is exactly the same, right? Okay, so that's the coefficient of dynamic friction, right? So that's basically mu n, right? Mu n, okay, right? And then if you expand it, n is mg, n and mg, like this. So F equals to mu mg, right? But what do they want, really? They want power. What's power got to do with all this? Power equals Fv, right? P equals Fv, right? So if you plug this in, since you know that it's the same as the driving force, there is mu mgv, right? So D is your answer. All right, so question 8. What's the next question? 9, anyone? 9? 9, no kick, huh? Oh, okay. Oh, sorry, what? She went online yesterday. Why? Why she went? You tell her 1:30. That's cap, ah? Okay. Then you tell her to log in now and hear me say that it's 1:30 today. Tell Sam says log in now and hear him say in person that it's 10:30 today. 1:30 today. Huh? Yesterday's lesson was 3 hours. Yesterday's lesson was 3 hours. Why? Cause I whack I whack and I whack and I whack and I whack all the concepts in Now maybe that's why she says cap, because if I end at 1:30, it's only 2.5 hours. Yeah, it's supposed to be 3 hours, right? No choice. Yeah. Okay. I have to try to squeeze in as much as I can. Come on. Done with this. Next one, 10. Do I need to do 9? No, 10. 10, huh? Right. Same question also. Right. So what do you think you were supposed to do here for question, like, this question? Well, like what's the, what's the underlying equation, or what's the underlying thing that you need to use here? Yeah, and Q equals MC delta T, right? So back in secondary school, you always had one object, another object, you mix it together, then Q equals MC delta T equals to Q equals MC delta T, right? Now you got 3 objects, then how? Do one by one. So you do the first two first. Q equals MC delta T, Q equals like MC delta T, and then you just, right? So 2MC, right? Delta T, don't just leave it as delta T because the delta T will be different, right? So for the first one is what? 60 minus T final, correct? And this is equals to 2MC T final minus 30, right? Cannot. So when you put something hot and something cold, how can you assume that the cold one heats up? No. I'm only doing the first two only. I'm not doing the third one yet. First two only. Right? Sometimes no choice, right? You herd the sheep into the gate. So I have to tell you, first two only. Just think of first two only. Don't go and do the third one yet. Don't think about the third one yet. Solve ready? Do you have the final temperature? How much is it?
Not yet.
Can, very fast one. This one, come on, come. Yeah. Sorry, I don't mean to call you Kumon. Faster. 45? Once you get 45 ready, right? Then now you go and mix it with the third one.
Then you will make the mass 4M.
Correct. Then the combined mass is 4mc, right? 45 minus T final equals to mc, t final minus 0. Okay? But what's the important thing that you need to be very careful of when you're doing the calculations here? Okay, I know for the first one it's quite easy lah. For the first one, you know the midpoint is the mid temperature, right? Okay, but the very important thing is if you're trying to work it out in paper 2, for example, right, just make sure that you get it correct, like 60 minus TF and TF minus 30. Like the term here, the delta T should always be flipped around to make it positive, right? Some of you remember this from secondary school, right? Your secondary school teacher has mentioned before, right? So just remember that lesson as well, right? All the way until now, right? So 60 minus TF will give you a positive value, TF minus 30 will give you a positive value. 45 minus the final temperature is going to be more than, right? It's going to be bigger than the final value, right? And then you take TF minus 0 here. Okay? Yeah.
Why you assume that the 30-degree one will become
Because I'm mixing it with 60.
it also makes it 0.
Yeah, so I do it step by step more.
So you just assume something first, then you see it.
I didn't assume. I just solve it step by step. Yes. Wait, hang on. If not, how will we do it? So a three-part equation, multiple, so something equals something equals something. And that's like primary school, right? 1:2:3, right? No, this is the way, right? This is the way. Obviously, this one we have never done it in the normal practices before. You look at all the textbooks, you look at all your school worksheets, you look at all the past year papers. This is the first time this has ever come out. It's up to you to decide how you want to solve it. How are you going to solve it? Is there instruction for you to how to solve it or not? No. Then how are you going to solve it? You solve it by breaking it down, step by step. So you do one first, and then you do the next one. Right? There you go. You doesn't matter which order you do also, no? You can do the 60 and the 0, and then you do the 0 and the 30. It doesn't matter which order you do. Yeah, but there's only about how many orders? 3 choose 2. 3 orders only. Huh?
Yeah.
What? What? Can lah, can. Okay, so I don't know what's the answer, but I guess you can get the answer. What's the answer anyway? Okay, sure. Next question, please. I got a. Who's that? Is that Navella? Navella, what are you doing with? Where are you? Why is there a forest behind you? Oh, shit, Holland V. No. I'm just telling you that I'm ending at 1:30 today. I'm supposed to inform you. Okay, bye. Mute yourself. Okay, next one. Come. What's that? 12. 12. This one? 12? Huh?
Yeah.
So does it have a units of joules per Kelvin?
Yeah.
You sure?
Data booklet.
Yeah lah, check the data booklet lah. I also don't know. Oh, then which one? The 2 and number 3 ah?
Yeah.
Okay. All right. So I got a feeling that 3 might not be quite right, Hey, wait. I think number 3 might not be quite right. I think number 3 is not quite right.
Why?
Like it looks right, but I don't think it's quite right.
It's not right.
I don't think it looks right.
It's
I
not
don't
right.
think so. It's not right. Then you have to. Okay, I give you a clue. Okay, it's inside your data booklet.
Yeah.
No. So it's inside the data booklet. So what does the inside? What's inside the data booklet that gives us, that proves us that number 3 is wrong? Like what's the equation? Huh? Hey, data booklet's available to you. No, data booklet not gate kept from you one. No, there's no gatekeeping here. Special one. Come. E what? EK with what? With a bar on top. EK. Okay. No. 3/2 KBT, right? Can you make KBT the subject? Sorry, KB the subject. Then what do you get? 2/3 EK over T, right?
Then why is it?
Because the 2/3 is not there. What? They say equal, right? If you put a proportion, then okay lah. What? But the 203 is not there. I'm asking you to use the data booklet to tell them that they are wrong. This statement tree is wrong, right? Using their own weapons against them, right? Okay, Hey, hold up, This is me trying to help you, no? I'm not the bad guy here.
Don't worry, we don't need that.
No. She's not happy. Right? So no choice. You have to really take it literally that 203 is not there. So we have to accept that number 3 is wrong.
Yeah.
Okay? But how about number 2 though?
Yeah, that means
Oh,
it's also
yeah.
not the same one.
Huh?
No,
It's the same.
three number two cancel lah.
PV equals to small n big RT, PV equals to big N KBT, right? So essentially, if you look at it, so small nr equals to big N KBT, right? Sorry, KB, right? So nr equals to big N KB, and then you make KB the subject, you realize that you get KB equals to small n over, right, big N like that. Am I right? Yeah, like this, right? Okay, so then you need to recognize that small n over big N is Avogadro's constant at the bottom. Yeah, yeah, it becomes NA. Can, whichever way you want to do, can. Yeah, can. Okay, number 12 done. Next one, come. Next one. 13. Uh-huh.
Yeah, why? I got it wrong. It's either A or C then. Because
What does negative acceleration mean? No, what does negative acceleration mean? You don't know what negative acceleration is?
is it opposite?
Wait, pendulum? Can you think of a pendulum?
Yes.
Alright. So where's the positive side? Which side? This side? Positive side, this side, right? Okay. So displacement is positive. Where's the acceleration pointing? Where's the acceleration pointing? Where's the acceleration pointing?
Yeah.
This side. SHM, right? SHM,
Oh.
opposite direction, right? So when you're at a positive amplitude, you will have. There you go. That's what negative acceleration is.
Oh.
Okay, next one. Come. 15. Request for 15. What's this? So point source, amplitude Z, distance L, right? And then basically now it's 2Z, right? How much does he have to move in order to hear the original intensity again? So the intensity that he hears here is what? Is proportional to Z squared, right? Amplitude. It's in the question. Yeah. Right, amplitude Z. Okay. So intensity is proportional to amplitude squared. Intensity is also inversely proportional to L squared. Am I right?
Yes.
Yes. Okay. So when you double the amplitude, how far should the L2 be in order to get the same intensity, right, as before? Yeah. Is it not 2L?
No, it's L. 12 minus L.
Oh, how much? So L2 is equal to 2L. So the difference in L is L. Damn tricky lah. This one is damn tricky lah. This one.
2 is 2L.
So we know that if you double the amplitude, if you want to hear the same intensity, right? Intensity is proportional to Z squared. Intensity is proportional to 1 over L squared. So Z squared and L squared are like proportional to each other. So when you double the amplitude, you would have to move 2 times the length in order to hear the same intensity, right? Because you need to divide it by the same, right? 2L squared, right? So it's like 2Z squared versus 2L squared. Then you can get back the same intensity. But the question ultimately asks you how much must he move by? Wow, tricky, right? These people, I missed out that move by. I would have chosen 2L as the answer. Damn.
Is that much?
This one is 4.23. Okay, 15 done. Next one. No, but this particular one, right, this amplitude and this one here, like there's only a very brief explanation of that. That's like 15 minutes only, but the rest of it is the usually the rest of the questions are all, the annoying ones are the ratio ones. So you might have to do some practices for the ratio ones. Alright, that's 15. Next one, come. What's that? 18 ah? 18, 18, 18, 18. So you know you have to use your left hand rule. You know you have to use the left hand rule. You all know that you have to use the left hand rule? Left hand rule, okay? Alright. So where's the force acting on the wire?
Everything is out.
Then okay lah, then the answer is D lah.
Now that is yes.
Huh? You know that everything is outwards? No, as in like the yesterday's class couldn't even realize that it was an outwards force. It was an outwards force. Which one would be the best answer? D is the best answer. Wait, what? Why? I don't understand.
Into the head. It's force, right? It's gonna move out. Why do you think it's so key?
Like that? Like this. Feel first. Feel first of fingers. Feel first. Point into the page. Right? Stick out the middle finger. Right? Yeah, stick out the middle finger with the other fingers included, lah. Right? Don't just stick out the middle finger, lah. Right? Right? Like this. Right? Then after stick out the thumb. Then the force is outwards. Wait, I don't get it. You all knew that the force pointing out, but then you couldn't choose D. That's the thing. Why? You was mistaken by
myself.
By yourself? Question, wait, let me think about this first, Let's is there opposing force?
No.
Huh? There's an opposing force. So as the wire moves outwards like this, right? Then you can start talking about induced EMF, induced current. Yeah. So there's an opposing force. But okay lah, if you want to just keep it as to this basic concept, then yeah, it will increase the radius of the loop. How come you know it was pointing out? Why? Why didn't you choose D? Or you didn't know what was the thing?
I didn't read it wrongly yet. It was asking something else.
You chose the correct concept already. You didn't commit. Okay. 18 done. Next one, come. 19 19. How come nobody can do 19 I don't understand. Do you know what's the concept here? This one? Like, no, have you seen? No, they did this in school. What? But they did this in school. They did this in school.
Oh,
Yeah.
you have
Oh yeah, that's right. Oh yeah. He go robotics, right? This kind of thing, wow, subsui. What robotics more challenging, right? More fun, right?
Yeah, right.
Okay. Big M. Big M, where's Big M? Right? Is Big M moving? No. Draw forces on Big M.
Energy. Tension.
Okay. You have a hesitation on drawing forces. Yeah, always have to draw forces on. Alright, tension. Tension, Okay. Can you confirm for me that tension is equal to big mg?
Yes.
Guaranteed?
Of course.
Why? Good. One string, one tension. So the tension in the string above is also T, which is the same amount, which is also big mg. But what does it do for the small mass? So mg equals to Fc of small m, which equation what do you want to use? You got two choices. You want to use mv squared over r or mr omega squared? Mr omega squared. Why? Why did you choose that? Because it gave you period, right? Then okay lah.
Wait, I got here.
You got to here. Then you want someone to complete the thing for you.
Yes.
Why? Why? You cannot hire for people to attend your exams, you know. It's very hard to find people that look like you. I don't look like you. I cannot go into the exam hall with your IC, you know. Huh? No, not really. I didn't even try doing the A level one. No point. Yeah, no point.
Yeah.
Wow.
I just skipped.
Then you just give up. Then this is what you want me to say? Okay, tell me what you want me to say. You want me to solve for you or want me to scold you for not completing? Where the pi square go? Oh, this one is estimation. Yeah, this one's estimation. Yes, yes, yes. Okay.
It's 3/4. You say you can't make it up. Then you get wrong. You get 7. Then you get 7. Yeah. Okay.
Thanks for saying the things that I wanted to, but I did not say. Yeah, thank you.
It's Robert Farmer. Yeah, and also you must yes. What's up?
Fair or not? Okay, there you go. Now M over M. But yes, this is an estimation question, so you have to estimate some numbers. I think this paper has a few estimation questions, right? This paper has a few estimation questions, I believe. Okay, come next one. Okay.
My cookie bear.
See what?
Like, I just need some machine. I know. I just keep going. Yeah. Nothing else. But it's last. This is your surprise. Oh, so it will go to 4. So. Okay.
Can I move on? Okay. 19 done. Next one.
24.
20 what? 24. What?
22.
22. 22.
Yeah.
Uranium 237. Uranium 233. Is it still uranium?
Yes. Also, proton number remains the same.
Yeah.
So it should be 1 beta plus 1 beta minus.
I don't know. I cannot remember.
Oh, yeah.
What does beta minus do?
Isn't it?
So if beta minus decay, right? Decay, what happens to the proton number? Beta minus increases, right?
Yeah.
P plus 1.
Yeah.
Beta plus?
You know why?
P minus 1.
Yeah.
Alpha? P minus 2.
Oh, sorry.
Then you choose. Which one will end up with the same P?
Oh, so it's
Beta plus alpha.
No, beta minus, and then alpha. Because P minus 2, right? You lose 2 protons, then you gain back 2 protons. So 2 beta minus and 1 alpha will give you the correct answer. So B. 22 done. Let's go. 23. What's a paradigm shift? What's a paradigm shift? Jump scare. Woo.
Okay.
Huh? I don't know. Do you define what the paradigm shift in TOK means?
yeah, I think it's
So what's the paradigm shift in TOK mean? Change your understanding. So which one will give you a change your understanding? Let me see.
D.
change.
Walao, eh. Yeah lah, D lah.
Wait, you know now, like, the past few papers, they've been asking so many, like,
Actually, hang on. Hang on. This paradigm shift thing, right? Seriously, right? At some point, right? When does it stop being a paradigm shift?
Oh, that's why.
No, it's a paradigm shift at that time lah. What if in modern society this is normal? You know, the whole idea about like electron, this discovery of an electron, is that a paradigm shift? Is the discovery of electron is the discovery of electron yeah, it is at that time, because they all thought conventional current was positive charge flow to a negative charge, right? Right? Electron flow was a like, ooh, now is that a big of shock? No, right?
But it's still considered paradigm shift.
At that time lah, to the ignorance ah. What? Yes.
Oh. Wait, so what is a paradigm shift?
Huh? A paradigm shift is something that challenges the norm, right? Challenges the norm, right? So we know that energy must be conserved. We know that mass must be conserved. So the idea of conservation of mass energy is a paradigm shift because, you know, who would have thought that when you lose mass, you create energy? Yeah, but that kind of requires you to understand the history of physics. You understand what I'm saying? Like you need to kind of like know the timeline, right? Because okay, if let's say you ask a modern scientist, someone who went through the primary school and then primary school already teach them nuclear physics already, for example, then you ask them like, is it very shocking that mass can be converted to energy? They'll be like, no. Why is that? Why is that shocking? Right? That's not shocking. So this kind of questions, right, is damn waste time one.
Question. So you always know it's math.
Yeah lah, more or less lah, right? More or less, yes. Right, this kind of question is damn waste time one. Come next one. Oi, what's up, Dylan? Yeah, what? What you're talking about the later chapters, is it? Yeah, sure. Yeah, especially for Heisenberg, Schrodinger, and all that. Those are all paradigm shifts, man. Because those are the things that challenges the norm, right? Like electron as a yeah, anything from chapter 12, like generally, right? So mostly chapter 12, but 7 also, like, actually, right? As the more recent discoveries are paradigm shifts, right? Yeah, that's quite annoying. 24, what do you need 24 for? What's that? What's specific energy again? What's specific energy? Tell me.
Kilogram.
Joules per kilogram. Okay, so how much joules is produced from yeah. So a fusion reaction of one nucleus of this one and one nucleus of this one converts this to energy and converts this to energy, right? Okay. So what's the ratio of specific energy, right?
Yeah, how?
Yeah. So you have to do joules per, right? So energy per unit mass, right? Of hydrogen over energy per unit mass, isn't it? Isn't it the mass the same? Oh no, it's 10 times, right? It's 10 times, right?
How?
No, there, you see this one, the number?
Oh, it's 10 times.
No, as in like, hang on, but I need to confirm the energy though. So how much energy does the first one produce?
No.
Huh?
Is it 0.091 times 0?
Yeah, lor?
You have paper, right?
No.
Then
That's why I said this paper had a lot of estimation. So 0.019 times 931.5 over 0.019. Is it? Yeah, lor, it looks like it will cancel out, right? But it's not, answer is not.
the answer is, was it C?
Wait, Hey, no, does it?
Because actually all the constants will cancel out, right? So you can't just put the energy in you over mass and then like the cause they are because everything is just cancel out.
No, then what's the answer then?
That's it. C.
Then how does it become C then? Wait, I can't see it myself. I need to work it out, right? Times 931.5. I don't expect you to be able to see it also, what? Do you expect me to see it? No, right? I expect you to work it out. Do you expect me to work it out? Yeah.
Yes.
Same lah. So you all work it out also lah.
Right.
Yeah. You don't expect me to see it, right?
So actually just
Take U as the energy. Wait, hang on now. Oh shit, no. This math is wrong. Yeah, this math is wrong. So this is the math defect. This is the math defect. I mean, guys, it's good that the option didn't include one. If not, I would chosen one, right? So you can see that they are kind of like they're trying to egg you on and trying to make you think about this. Why is it not one? So it's actually, again, specific energy is energy that's produced divided by mass of reactant, mass of fuel, divided by mass of fuel. So for hydrogen 2 and hydrogen 3, total mass is 5. And for uranium is 235. Right?
yes, again.
Yeah. So the 931.5 will cancel out anyway. Right? But I'm just showing it to you because it's there. And then what is it then? It's 10. Wait, then divide by 10. No. No. On top is 0.019, then bottom is 0.190.
So technically it's 0.09.
So C is the answer, right? Yeah. Yeah.
But 2.7. Yeah, then you run out.
24 done. Let's go next one. 29. 27 only,
Yeah,
29, 29. Hey, 29 is the one I told you, right? Huh? You need 27. 27. Oh. When you're trying to do this question, this is what again? What's the equation you need to use? Can you give me the full equation? A rho, V cube. What's the equation for? Is the equation in data booklet?
yes.
What is it for?
Wings.
Wind turbine, right? Okay. And do you do you know how to use it now? Okay, wind turbine, the equation. Okay, you tried it, huh? Okay, and I try it on your own, huh? 27. You.
Yeah.
What concept is this? Thin film. When it comes to thin film, the moment you see a thin film question, you have to check whether or not you use the data booklet equation or the reverse data booklet equation. Are you aware of that? No, as in like you are aware now, but then did it not occur to you that you have to check whether or not, or do you not understand why you have to use reverse? What? When to use reverse and when to use like the data booklet, is it? You have no idea that means. Okay, good. All right. Ask me for the video. Yeah, that's the only way, because otherwise I have to explain this right from scratch. It's too long already. Okay. So the whole idea here is that depending on the refractive indices of what you have here, right? You will have to judge whether or not you have to use the data booklet equation on its own or reverse it. Okay. So that one you need the video. But for the one who did this, do we reverse the data booklet or do we use the normal one? We use the normal data booklet equation. Okay. And what do we want to achieve here? Do we want constructive or destructive interference? We want constructive interference. Constructive interference of what?
The light.
Of what light?
Violet.
Where?
In the oil. Yeah.
Absolutely not. In the air where? Outside. The reflected light rays. Okay, so if you didn't realize that the thin film interference refers to the interference of the light rays that's been reflected back out into air, then again you have to watch the video, because that means that your entire understanding of thin film interference is kosong. Correct? So you need to talk about whether or not these two light rays are interfering. So do you understand why there are two light rays like poking out like this? Right? Have I shown you the glass block before I shine the laser? Where's my laser? Oh, hey. So basically, when you shine the laser beam into the glass block like this, right? You can see that it goes through right on the floor. You see it? Okay. Hey, look at the top here like this. Oh, it's very bright. Actually, today is a very bright day. Like this, right? Then when you look at the top there, do you see the two dots on the ceiling? Yeah. Okay. That's what the interference is all about. The interference is of the two reflected light rays. So why are there two dots? Because one is reflected at the surface, the other one is reflected from the inner surface. So you got two light rays coming out, and these two will interfere. So whether or not you want constructive or destructive interference, you have to read the question. What's the question one? What's the minimum thickness so that the color of the reflected light is violet? That means what do you want? Do you want constructive or do you want destructive? You want constructive, because basically they want reflected light to have violet, right? So you need to have constructive interference. Okay, but because we know that it is normal data booklet equations, and we know that it is constructive interference. So what's the equation that we need to use here? What's the equation? Come read it out to me. CI for violet, right? Which is a standard data booklet version, right? Not reverse, huh? What's it?
M plus
No, read out the whole thing. Why you all like to read only the back part one, huh? Read the whole thing.
2dn equals to bracket m plus half lambda.
Okay, right. So this will be the condition for constructive interference of violet using the data booklets version. What's D?
The distance
Thickness of the film. What's N? What's small n?
order
Refractive index of the film.
bigger.
Okay, what's M? M is the order. M stands for McDonald's. You order. Okay, so M here. If you want the minimum thickness, M here is 0. But if you look at the other equation, right? What's the minimum order for the other equation, M? What's the other equation? Destructive interference, M must be what? 1, not 0, right? 0 means no thickness. Okay, so this one here, for this equation, the minimum order, that means M is equal to 0. That means half lambda. Okay, right? So essentially, okay, at some point, right, I'm going to just say it now. At some point, what you need to do, right, over the next 2 weeks, today is the second last lesson, right? Second last physical lesson. So over the next 2 weeks, right, you have to pick up your data booklet and go through every single alphabet on the data booklet and ensure you know exactly what they are, right? Not your own version of physics, like the actual version of physics, okay? Right? Not like D is the distance and then N is the order, okay? Can right? So you need to check that. 27 done. Let's go on the next one. Right? Resolution. Anyone? Resolution. Anyone still confused by this? Right? If you're still confused by this, just go ahead and ask me for the video. There is still time. Okay. 29. 29. I did mention that I made a mistake. Right? In the group chat, I mentioned that I think one of the lessons I made a mistake. The other one I didn't make a mistake, but I made a mistake because I said the wrong thing. Okay. In that video, in that lesson, I think I accidentally said that when the two objects are moving, right, you can use relative speed for sound Doppler, right? So the answer is no, you cannot. You cannot use relative speed for sound Doppler. Okay, I'm gonna do any other. Okay, so revision, right? So like the last minute revisions. I have come up with a list of the things I need to go through: circular track, bank track, capacitor, and Doppler, right? So I'm gonna go through those things one more time. I'll go through Doppler one more time, right? I'll make sure that you understand this once and for all. But you need to understand this: sound Doppler and EM Doppler are two different sets of equations. Sound Doppler, right? Sound Doppler and EM Doppler are two different things. Okay, sound Doppler and EM Doppler are two different things. This is sound Doppler. So sound Doppler, you cannot just rely on relative speed. You really would have to, right, calculate the perceived frequency emitted by a moving source, and then you have to calculate the perceived frequency, right, by the moving observer. Because he's moving. Because the siren is directed at him. Have you not been in a car where the ambulance is right behind you? Wee-oo, wee-oo. No? No?
I didn't see the word
Dude. Even if I didn't give you this part here, right? If I give you this diagram here, what do you think the car is there for?
I don't know.
What this kinematic question,
No, I have no comment.
You got common sense. that you were just waiting for that. Okay, all right. So you have to work out both equations, right? It's just made fun of you only a few times only. Why you cry? So you have to use the equations, twice. You have to do the equations twice. So F prime for the moving source, F prime equals to F, right? What's the equation for moving source? What's the equation for moving source? Hey, you're her data booklet.
F prime equals F bracket V over V plus minus US.
Okay, decide. Whether is it plus or minus? Is F prime higher or F prime's lower? Why higher? Because it's moving towards the car, so F prime must be higher. So in order for F prime to be higher, what must be the plus minus be? It must be a minus, so you get rid of the plus sign here. So it's V minus US. Okay? Alright. Do we have to fill in the numbers? Then yeah, we do. So F prime equals the original F, V over V minus what? 40. Okay? What does US stand for? Speed of the source. What's F double prime? F double prime will be whatever the F prime is coming towards it. So F double prime is F prime multiplied by a factor. So now you're dealing with a moving observer. What's the equation of moving observer? V plus minus UO over V. Okay? Right? And then so what do you choose? Do you choose plus or minus? Because the car is moving away. So you have to choose minus. So F double prime is F prime times V minus UO over V. Right? Because the fraction must be smaller. Then you take your F prime here, you sub it inside, you sub in your UO to be 20, right? Then you get your answer. Yeah. Okay? So you can get your 29 somewhere. Right? But I will do one more round of Doppler revision soon. Okay? Either this coming week or during that gap between the exams, right? The 29th onwards. Okay, let's do the next one.
30.
30? 30? Why 30?
I just don't know.
So how do you know what's E field strength then? What's E field strength between plates? Yeah, V over D. Right? E is equals to V over D, right? So is that, does that give you V? Does the Q over C give you V? Yes, it does, right? So it does look like first statement is correct. Yeah? How about the next statement? E field lines are right angles to the plates.
Yeah.
E field lines are always right angles to the surfaces, any surface. Even if I give you like this, right? A ball and a plate like this, right? I give you a positively charged ball here, and there's an earth plate like this. Can you draw the field lines between the two? How you draw the field lines? You have to draw it 90 degrees to the surface. You have to draw the 90 degrees like that.
Aren't each lines the
That's for isolated charge. But when you have two interacting objects, you have to draw it such that the E field lines emerge from one of them, right? Perpendicular to the surface, and then it either, then the other side also must be perpendicular. Now, the reason why these two are joined is because this plate is Earth. So if it's Earth plate, what will happen to the plate? It will become negatively charged
So each lines are always perpendicular,
to the surface.
no matter what.
Yes. All right, and they can never cross. Right. Potential surfaces are parallel to the plates. Is that true?
If your lines are perpendicular, then
No. I mean, okay, so potential surfaces are always perpendicular to the field lines. So since the field lines are right angles to the plates, and therefore they're parallel to the plates here. So statement 1, 2, 3 are all correct. All right, let's go. Next one. 31. Oi, why are you asking this question? Okay, what's this? You place a charged particle in the middle here, is it? What's a... Can I just call it Q first? Oh, they want me to find Q. So I have to put Q. Right? Q. Okay. Does it experience a force? Why? Why does it experience a force? Because it's an E field. Right? So what's the relationship between Q, force, and field strength? F equals QE. Which part? Yes. Yes. So, okay, so no, the thing is I'm trying to spot what you are confused by. So a lot of people see this, right, and they think it's energy. It's not energy. So don't forget, topic 5, topic 10, capital E stands for E field strength, right? E field strength is F over Q. E field strength is V over D. Okay? Okay. So if you need to refresh on 5 and 10, please, right? You know what to do. Okay. I think it gets somewhere, right? Q goes to, yeah, D looks like an answer, right? Yeah. Okay, next one. 32? So a bit different. 37? 37? 37? 37. Still working. Still working. No working. Wrote what? What? A? Where got A? Okay. Let me ask you, how do you think I'll solve? I'll teach you this. Huh? Watch video. Let's say I want to solve it to I want to show you how to solve it now instead of referring to the video, like how I dumped her onto thin film interference. Right? So let's say I want to show you how to solve it now. What would I do? What would I do? Really? You don't understand my style at all after all this time. I will draw it out. Yeah, I'll draw it out, right? Yeah. No, so the thing is, if you didn't realize that, every time I try to help you solve a question, I've been drawing it out. You see all the screenshots I sent to you on the WhatsApp group chat, I've been drawing it out. What's the whole point of me drawing it all out? Yeah, that's the word. Yes. So we're gonna try to visualize it now. Right? Why? You think I draw for fun? I draw it for myself also. If you ask me if I were to if I sit in as a private candidate for IB, right? You will see these workings on the paper itself. Because I have to draw it out for myself to see sometimes. Okay. Never. Huh? Do I want to spend the time sitting in the exam, or should I go and spend time with my kids? I'll spend time with my kids. Maybe after when they grow up already, I got nothing to do, then maybe I go and sit in. Right? It's like, oh, what's this 55-year-old doing sitting in for IB exam? Huh? Oh yeah, maybe I should, right? Yeah. Just for kick, right? No lah, private candidate sit somewhere else on. Okay. Yeah, I'll be just making them depressed, right? Okay, minimum frequency for which the ejection of the thing possible is F, right? So what does this tell you about the work function of the plate? HF. And then what am I shining? What color light am I shining on?
Monochromatic electromagnetic radiation.
I know. Let's skip to the next sentence really. Second sentence. You know how to read English, right? Second sentence. Come on.
Radiation of frequency
2F. The work function F, but I go and use 2F.
Yes.
So what's the photon energy? 2HF. Okay. So if I use photon energy or 2HF, but the minimum energy to come out is HF, then what is the leftover? Yeah. So what's HF? What's that? What kind of energy is it? You're just thinking on the math. Yeah, think of the physical thing, right? So it's the Ke of the photoelectron, right?
Yes.
Right. Okay, good. Then what happens when I use 4F on the same plate with the same work function HF? Then you write down 4HF minus HF, then equals what lah? What you chase me for?
I mean, wow.
No, don't need to wow, don't need to chase. Just take it and then move on. 37 done. Next one, come. Anyway, the answer is what? 3K.
Yes.
Next one, come. What? No. I know. Nothing else. 30 what? 34? You feel like you got it wrong? I'm gonna tell you this, okay? If you leave the switch on for too long, right? Nothing happens. There's no current in the ammeter. or open, is it? The switch is open. Okay, firstly, right, as this is running, right, as this circuit here is running, right, am I right to say that the switch is closed here, right? And then there's current flowing inside it, right? As this flowing and all this kind of thing, right? Is there induced EMF, induced current in this other coil? Huh? Why you assume that my answer is no?
Someone said no.
Is it just constant currents and
Uh-huh.
change in magnetic flux is constant, so that's like no change in the constant magnetic flux, so there's no change in magnetic flux, so there's no induced EMF, there's no induced current.
Thanks for saving my breath. Yeah, lah, correct. Yes, those reasons. Then what happens when you open it?
Oh, there's change in magnetic flux, so there's
Okay?
so it's 0 and non-zero, falling to 0. So it's A. I hope it's A.
Yeah, it's A. Okay, good. All right. Hey, but I won't be there to show you my face, Right? Yeah. You try to remember, okay? Hey, please, don't put me like some. Hey, please, show it. Hey, no, thanks, don't go and put my face there. Wow, jialat. That cannot, like praying like that. Can I get another question from here or don't have ready? Don't have ready, I'll move on to paper 2. Right? You can come back again if let's say you realize that the pace of the class is a bit faster because we finished 2022 today, this coming Monday, Tuesday, Wednesday is 2020. Then you just catch all the questions and then try it, right? Because next week there's no lesson. So next week you do your math or you do some more physics or other during the 29th period. So next week no lesson, next week 19th, 20th, 21st, 22nd, 23rd no lessons because I know your math is 24th. Right? And I want you to focus on your math. All right? What? So the next lesson is only this period of time, 29 to 31st. Right? And even maybe the first, but I try not to touch the first because I know there's something else on the 4th, is it? What else is on the 4th? Another math,
No, that's
fourth is chem, right? Chem. So second, third, I'm not gonna see you guys also. Then I will. But I did mention to the other class as well. I will open consult here, and around here as well. Maybe 21, 22 open consult, 17, 18, 19 also open consult. Open consult means that if you have any more questions or you're still not sure or whatever it is, I will just open some time slots, right? During this period of time, and then like either you all come down or you all go online or whatever it is, right? So it's just no official lessons. That's all. Okay. That doesn't mean that I'm not communicable. I cannot be. Yeah. Doesn't mean that I'm radio silence from you guys. Okay. This one. Paper 2. No kick.
No, you explain
Ah.
2A part.
I got a 1C. Wait, I got 1C. 1C? 1C? This one here. First 3 seconds of motion, is it? Huh? First 3 seconds? First 3 seconds is what? Is the raindrop is gaining speed, right?
yeah, but wait,
Uh-huh. They give you value. Value?
Then
Uh-huh.
but the thing is, they subtract the values of B and others.
Oh yeah. I mean, if they give you value, then yes, you have to. So you have to show that there's a loss of GPE.
Yeah.
For 3 marks lah, right? Right, 3 marks lah. Don't ask me like, oh, do I have to do so much? Right, 3 marks, guys. Loss in GPE, right, is how much? Gain in KE is how much? And then what's the discrepancy?
Why do you find it?
Aren't you worried that there's a discrepancy? Doesn't it not concern you that there's a discrepancy? I mean there is So then you have to but you have to determine the energy transfer to the air. No, that's the answer, what?
Yeah, that's
Sorry, I thought the first word was describe. It's determine. That means you have to go and calculate it out. So the difference in energy is to the air. Yeah. What energy is this? Yeah, what energy is it? Like what kind of energy is it? No, that one is after 3 seconds. No, so what's this energy? No, kinetic energy. Right? So the raindrop is falling through, right? It's falling through, so the air is being pushed away, right? Because it's overcoming drag, right? You can either say that it's thermal energy to the air, right? Or you can say it's kinetic energy to the air, or you can even say like it's kinetic energy of the particles, the air particles, right? Yeah, yeah. Okay. Then how about for more than 3 seconds? Ooh, this one is a good question. Bonus 1 mark. More than 3 seconds. Okay, yeah, you see, more than 3 seconds is what? What's happening more than 3 seconds here? What's that? What's that constant speed called? It's called terminal velocity. So at terminal velocity, can you tell me what's the velocity like? Constant. So is there an increase in KE?
No.
There's no increase in KE. But does it still lose GPE?
Yes.
Yes. So how come the raindrop still loses GPE but does not gain KE? I mean, basically heat and sound of the surrounding air, right? So the GPE loss, right, is converted into heat and sound, right, due to drag, due to the air resistance. That's it. That's the bonus 1 mark. Okay? Don't ask me, can I say that it's temporarily converted to KE and then after that converted to heat and sound? Because a lot of people will ask me that. So I'll tell you this, okay? You just go with the overall conversion. You've done this since secondary school, that's a problem, right? Since secondary school, any object that's moving at maximum speed, any object that's moving at terminal speed, right? The conversion is from the fuel into heat and sound, right? Let me give you an example. Car, right? Can a car reach a maximum speed? Can it reach a maximum speed? Can a car reach a maximum speed? Can, right? Makes sense, right? A car can reach a maximum speed, right? How do you know that it has reached a maximum speed? It doesn't increase the speed anymore, lah. So let's say the maximum speed, right, is what? 90 km per hour, for example. Right? Let's say whatever at whatever magnitude that you are pressing the accelerator is at maximum speed of 90 km per hour. Can? Right? Why is it at maximum speed? Why is a car at maximum speed? As the driving force, right? So the driving force, right? The driving force is the same as the resistive forces, correct? So the driving force here and the drag here will be the same, right? So what's the overall energy conversion of the car? I mean, what does a car burn? Fuel, right? So what kind of energy is that? Chemical potential energy in the car, and then what is it converted into? So if you say KE again, that's wrong. Because if you say KE, that means the KE is supposed to increase, the speed is supposed to increase. It doesn't increase. So the fuel is simply just used to overcome the drag force and the resistive forces. So the chemical potential energy, the CPE, is converted to heat and sound. That's it. I know there are moving parts in the engine and all, but the overall energy conversion is CPE into heat and sound, not to KE. The moment you mention KE, right, they'll mark you down.
But is it not like CPE to KE to
That's the first thing I said just now. Yes. Just go for the overall. Just talk about the overall change. It has happened since secondary school. Okay? So that's the answer for 1C part 2, right? GPE converted into heat and sound of surroundings, not KE. Okay, I got a request for 2A part 1. 2A part 1. Okay, 2A part 1. Unfortunately, this question here, right, the panel, the solar panel, and the roof tiles are two different things. Notice how they didn't give you the albedo for the solar panel. They only give you for the roof tiles, right? Then the question is asking you about the solar heating panel, right? So we treat the solar heating panel as a black body. So the absorption is just, I mean, yeah, it's just one. The emissivity of the of the solar panel is just one. You understand that?
question?
Wait, yeah, is it about this one? Okay, then you hold on. Okay, all right. So for this one here, if you want to increase the temperature to 30 degrees Celsius, that means from 15 to 30, that means an increase of 15, right? Time of 1 hour, so you have to find the time in seconds, right? Then you have to find out what's the right incident to the panel is 680 watts per meter square. You need to find out what's the area of your solar panel. I mean, that's a minimum area. So you need to figure out how much energy per second you need, because this 680 watts is the 680 joules per second per meter square, right? So you should be able to work it out based on that. Anyone have any issues with the calculations here? No? Okay. If not, then I want to talk about the roof tile. I want to talk about the roof tile. Yeah, I want to talk about the roof tile. That's the next question. What's the temperature of the roof tile, is it? Yeah. All right, so let's talk about the roof tile, okay? So if I'm going to explain to you the roof tile, I will draw the roof tile. Right, there's a roof tile. Have you seen the advertisement for the Japanese advertisement for the roof tiles? There's a whole bunch of like guys like tied up together. Yeah, that's that weird advertisement. The Japanese advertisements are always weird. So what's the incident solar radiation? Incident solar radiation? Incident solar radiation? 680 lah. 680 watts per meter square, right? 680 watts per meter square, everyone? Okay. How much is absorbed by the roof tile? 0.8 of that. Okay, so you're saying that the amount that's being absorbed is, right, the amount that's absorbed. So the intensity absorbed, right, intensity absorbed is equal to 0.8 times 680, which is how much? 544. Okay, 544, 544. All right. The tiles will reach a certain temperature, and your job is to determine the temperature, correct? So my question now is, how much does the tiles emit? What's the intensity of emission of the tiles? Let me use what color? Wait, I use orange. Right? I use green. Green. Okay, I use yellow lah. All right. So the tiles will emit, right? Emit downwards, emit everywhere, correct? So they absorb from one surface but emit everywhere, correct? Okay, but doesn't matter because we are dealing with intensity. Intensity is power over area, right? So, but here's the thing, right? So you need to understand that the roof tile actually absorbs from one area but emits in both areas. The roof tile absorbs only from on one side, but when it emits both sides. But it doesn't matter. It doesn't matter because we're dealing with intensity already, right? So 680 is the amount of power per unit area. Okay, so the amount that we absorb will be 0.8 times 680, right? So it's 544, correct? So my question to you is this: how much must the tile emit outwards? No, how much must it emit? Not theoretically. So this is the part where you need to remember the emissivity, right? Okay, so the emissivity makes you feel like it will emit less, right, than 544, which is wrong. The amount that's emitted is 544.
Why?
Right? The amount that's emitted is 544. Right? Is the whole idea again about like how the Earth's temperature is constant. But why is the Earth's temperature constant? I mean, apart from global warming, it doesn't matter. But why is the Earth's temperature constant for all this time, all these millions of years? Why has Earth's temperature been fairly constant for so long? Yeah, correct lah. Because what you absorb, you emit. What happens when you emit less than what you absorb? Yeah, then the temperature will increase. What happens if you emit more than what you absorb? Then it will decrease, right? So it's a thing, right? So it's accounting, energy accounting. What goes in must come out. So the amount of energy that you absorb is 544. The amount that you emit is 544 also.
But emit on both sides. So emit on both sides.
Yeah, but that's intensity, you see. So the intensity of emission is 544. Okay, hang on. So when we do this calculation, right? Actually, I haven't explored why they didn't divide by 2 because it's actually both areas, but it doesn't matter. I think the answer is something like 544 is equal to E sigma A T to the power 4, right? No, sorry, there's no A because that's already the intensity of emission, isn't it? It needs to emit 544, right? So then you put the 0.97. So the idea here is that the emissivity, right, will affect the temperature, not the amount that you emit. Okay, I'll give you another example later on, but for now you just understand, right, that you need to put the emissive. Does this give you the correct answer? 544 equals to 0.97 times sigma, then t to the power 4, then you work out what t is. Is that the correct answer? Oh yeah, check the answer please. I'm not the mark scheme. I don't know yet. Just check this one first, then I come back to you on that one. Yeah.
Yes.
Yeah?
Wait, so if it doesn't affect the
Wait, hang on. I got a cross talk here. Yes, Dylan. Yeah, it's not right. So this one here, that one was in the textbook. So now I need to go and do a bit more research. It was in the Oxford textbook that usually for most services, right, they will always take emissivity as 1 minus the albedo. But obviously this is not. So, I'll give you a conclusive statement later on. But that one was only from one textbook. All the other textbooks didn't have that. It was only from the Oxford textbook. I can show you the picture of it. I can show you the screenshot of it. Right. So I don't know what the Oxford do that is not the same as what IB thinks. Yeah. But I'll tell you this, okay? Knowing this, seeing this from the IB, right? We now know that it is not true. Right? So it doesn't add up to 1. Okay, hang on. Yes, wait, Yasmin first.
Why is it not 544?
That's a good question because I thought it would be divided by 2. I would imagine that it emits both sides, right? So while you absorb the power, right, from one area, I would think that it will be the absorption will be 544 times A. Then during emission, it should be 544 divided by 2A, right? For the intensity of emission. But I'm not sure why they kept it as 544. I think this one here is a mistake on their part. I think they forgot that the roof tile will emit both sides. Right? Yeah, I think they forgot about that themselves. The earth one is divided by 4, right? Because we absorb from one area, but when we emit from 4 areas, right? 4 times the area. So that's why we divide by 4. So honestly speaking, I really have no idea why they didn't divide by 2. I would have wanted to divide by 2. Okay? But if let's say you do this and you want to show them that you know that it emits both sides, right? Then if you let's say you put a 2 here like this, right? Then you write a statement down. You say that the roof tile emits from both sides of the tile, right? And see whether or not their logic will challenge them or not, right? Because the examiners will sit down there and then they'll be like, oh shit, we said the wrong question. Good, right? Throw them into doubt. Yes.
Like, in a real exam, should I divide or should I just be?
No, like I say again, if you divide it, then write a statement saying that
How do you know if like the actual answer key will divide or not?
you don't. I won't know also. I'm just telling you that you just have to be confident enough to know that whatever you put down, right, it makes sense. And if it makes sense, then they are caught. I would love to catch them all the time. Don't you get it? I'm always trying to catch them making mistakes. Right? I would love to catch them like, oh, you didn't divide by 2? Did you think that the roof tile only emits heat outwards the same way it came from? Do you not consider it emits these 2 ways? I will catch them with their pants down on the ground. Oh, right, you're exposed.
I don't understand why you see that the intensity doesn't affect the.
Yeah, because I haven't finished it.
Oh, you haven't.
Yeah. So if you divide by 2, because logic tells you that you absorb on this surface, but you emit both surfaces, right? Then you get a temperature here. Then I suggest that you write down a statement saying that the emission occurs on both sides of the roof tiles, right? And then let them go and decide whether or not they have to, no choice but to give you the mark. The mark scheme probably didn't say anything, right? Yeah. The mark scheme only took 544, right? Yeah, because in their minds they're thinking, oh, absorb this way, then emit only also this way, right? Yeah, forgot about material science, right? Okay, so the mark scheme does say just use 544 equals to 0.97 sigma t to the power 4, and then you find the t, right? So now let's explore what does emissivity really do then, okay? So let's say we have 2 bodies, right? One is 0.8 emissivity, okay? Okay lah, maybe not 0.8. Let's say we just use 0.97 emissivity, and another one perfect black body, the emissivity is equal to 1. Okay, all right, and then they have the same temperature. Let's say they have the same temperature. The same temperature. Okay, which one emits more? Because we know that P is equal to E sigma AT to the power 4, right? Okay, so for the same temperature, right, this one will emit more power. That means the power of radiation is more than this one, right? I mean, it's a bit of an exaggeration because 0.97 versus 1, right? Right, the power will be more. So emissivity will affect two surfaces when you're comparing two surfaces, right? For the same temperature, the one with a high emissivity will have a higher power of radiation, right? But we are not comparing between two. For this question,
Okay.
we're not comparing between two. We are looking at that tau only. We are looking at this tau only.
Like, it's still in the amount emitted.
No, so we are comparing this one tau and we ask ourselves, how much energy must this tau lose?
Yeah.
Right? It must lose the exact same amount that it absorbs.
Why is it not
Right?
like
So we cannot multiply the 0.97 to the 544 because it needs to lose 544. Because we're not comparing between two different taus. If you compare between two different taus with two different emissivities, then I understand at the same temperature, right? So this tau here, you see, the thing is this, right? The challenge I have, right, at this point, right, in the last couple of weeks or so, is students taking the literal sense of the equation, right? Like for example, like okay, what's the other one? The other day I just went through this one with someone. What's the definition of speed? Distance over time, right? So the student was saying that, oh, but then speed is inversely proportional to time. So as time passes, distance decreases. No, but this is, no, the problem is the student is just looking at it and looking at it from a math point of view. From looking at it as a literal variable, like, don't care what it actually physically means, right? So the physical sense of it must be, it's just like F net equals MA, right? I told you that, right? Apply more force, suddenly become more mass, right? So the emissivity here, I understand emissivity affects the ability to radiate heat, right? It's not a perfect emitter. But we also understand that we're not comparing between two roof tiles. This roof tile receives 544, right, times A of power. It needs to emit out 544 times A of that power, the same amount of power. Right? So we can't go and multiply the emissivity to the 544 because then we are saying that it will emit less. But if it emits less, what will happen to the temperature of the roof tile? It will increase. Then you don't have a steady temperature anymore. Okay? Right? Yeah lah. So it'll be a bit too low, right? Yeah, it'll be a bit too low. So that means that, I mean, honestly speaking, that means that they, like, we have to understand why they messed up lah. Yeah, we have to understand why they messed up the thing. Well, let me see first. What's wrong with the roof tile being -7 degrees Celsius anyway? Yeah, I mean, it's a cold country lah. All these are all white people problem, right? That's why they are in the country that needs a solar heating panel lah. I guess no, hang on. Like, I mean, don't be too surprised about the temperature unless you get something like -300 degrees Celsius. Then there's something wrong, right? But -7 is just maybe a cold country. I don't know, right? I mean, if you ask me, and if I think about it, I would write that down as answer, just to spike them, because I know I can get my marks everywhere else. You cannot, right? So then you do whatever you think is right. Then the right thing is to just ignore the divide by 2, right? There's only 2 choices, right? You make a choice, 1 or 2. It's not like you have a billion choices and you have to make one. Okay, right? But yeah. So the official answer is just this, okay? Which I find it, like, myself a bit like, I don't quite agree, because emission should be emission from both sides. right? So the intensity of emission is less. Yeah. You see, whatever power you receive, you must emit out. Now, whatever energy you receive must emit out. Yeah. Okay. All right. Ayo, why got people still asking me, do I need to know velocity selector? Why you ask me this kind of question? Why? Seriously, why? Sorry, what? B part 2. B part 2. Water is heated while the quantity of the storage tank decreases. So basically it's open, right? So when the air is hot, what happens? Okay. I mean, you can talk about the particles. What happens to the particles? And then no, okay. It's an open space. So technically speaking, if it's open, right? If it's open, right, the air will go out, but then the pressure remains the same because it needs to maintain the same pressure as the outside air. So the pressure inside here doesn't increase. You can say volume increase. Or how about this? The particles get more KE, right? They move faster, right? So as the for the same pressure, right, inside this air space, right, with more particles, some particles will escape to maintain the pressure inside, and therefore there's less particles inside. Yeah. Okay. Yes.
You can say like when temperature increases, pressure is constant, but the volume that it occupies increases, and some end is still again.
Yes. You can say that. Yeah, you can say that. They didn't ask you in terms of like molecules, right? But yeah, right. I just wanted to talk about the molecules. What's the next one? What's the advantage of a photovoltaic cell compared to a solar heating panel? You can store the energy.
They said the answer is the photo one is electrical energy, then which is more versatile form of energy.
Yeah, you can store the energy lah. Yeah, the word versatile is not the marking point. As in, like, it shouldn't be, right? I mean, what he's supposed to write versatile as like, do you have the definition of versatile? No, it can be stored, right? You can just say that it can be stored, right? It's fine. Anything that's logical is a. Didn't they give you other words to the effect? OWTTT or something? No. Okay. Sometimes Next one. What's the next one? Come. What's that? Yeah. 3A part 1. Yeah. You don't understand this graph? Why the amplitude isn't? Huh?
Okay, no, okay. The amplitude of Q is smaller than the amplitude.
Oh.
Doesn't matter like if I read it exactly.
Oh, this is for P. This is the displacement of P. And they ask you to draw for Q. Okay, and they want you to draw less, is it? How much lesser? Is it just half? Is it half? Is it half?
Yeah.
Look, measure lah. Measure.
Yeah.
Use that diagram and catch them. Yeah. Confront them. Is it half? If it's half, then half lah. Yeah. Use their weapons against themselves.
Not drawn to scale.
I would also think that's not drawn to scale. But if you show me a diagram like that and you ask me to draw a random graph like this, then I would use your own graph against you. Yeah.
I do the next scale.
Okay, come. Next one. What's the next one? C part 2. B part 2. What's B part 2?
Like they give the equation like E equal AC squared. So obviously C will change. Then I thought because it will change when the source change. Like yeah, it changes. Then like the frequency changes because the source is the tension changes, right? So why is lambda constant?
Do you not do this for your IA? Isn't it? Didn't oh? Who's the one who did the Chloe Lee's one or the Kyra Wong's one? Tension versus standing wave. Oh, I thought one of you did. Okay. Oh, you did Chloe's one. No. Trisha? Oh, not Kyra. Kyra. Oh, okay. Not Kyra. Okay. So I need you to remember this. The speed of a wave in any medium depends on the medium. So by changing the tension, you're changing the speed. First. As in like the first and foremost, you change the tension, you change the speed. How about water waves? What do you need to change the speed? What do you need to change the speed of water waves? This is from secondary school, huh? The what? The depth. Correct. The depth of the water. Oh. No. Listen, huh? So if the depth is this depth, the speed of this wave is constant. The speed of the wave is constant. Stop. So if I have a dipper that dips with a higher frequency compared to a dipper that dips with a lower frequency, for the same depth, both of them will be the same speed. Because they're the same depth. The depth of the water controls the speed. I sent out a screenshot last time. I did mention to you all that all the speeds of the waves, right, depends on their mediums, right? There was a screenshot somewhere. So even if you have very high frequency waves like this, like that, this picture here, versus low frequency waves like that, if they are of the same depth, they have the same speed. So speed is controlled by the medium. It's just like light in glass, right? Let's say you have a speed of light in glass like this, right? So let's say you have a glass like this, right? Let's say we talk about monochromatic light. Let's say blue, okay? And the light refracts like this, right? Right. The speed outside is the same. The speed inside is a certain speed. Okay, right? Or how about tension in a string, sorry, tension. So if tension is still the same, then speed of the wave is still the same. So even if you use a higher oscillator, right, versus a lower oscillator, a lower frequency oscillator, if the tension is the same, the speed is still the same. Okay, but then here in this question, we are changing the tension, we are increasing the tension by double, right? So we increase, so what will happen to the wave? The V will double, right? The speed will double. Huh? What?
The equation P equal AC squared.
Oh, so that means what? So speed of the wave. Oh, so that means it will be 4 times. Wait, what? Oh, root 2 times. Okay, so the speed will root 2 times, right? Root 2 times. Correct or not? But do you still want the same standing wave? Do you still want the same standing wave? Do you still want the same shape? Do you still want the same standing wave? Which harmonic is it? Third harmonic. Do you still want the third harmonic? Are they still referring to the same third harmonic? Third harmonic, right? They want the exact same third harmonic. No, the wavelength is still the same. Because it's the same length of string, and you still want the same third harmonic, right? So the V will be root 2, lambda still the same. Therefore, the frequency of the standing wave will be root 2 of the original frequency. Okay? That's the reason why. Okay, can Okay, good. Right, next one, come. C part 2. This one? What wave is this? You all got tricked. Sound wave go to liquid, what happens? It speeds up. This is all secondary school stuff, guys. Yes.
Oh my god.
So what will happen to the sound wave? This is not the first time that IB has tested this before. So the sound wave will bend away from normal. Oh, then you have to check for critical angle.
But is it critical angle for like from denser to less dense?
Yes. That means the light ray, the critical angle for light ray, that means traveling from
Denser.
slower to faster, right?
Oh my god!
So you have to check for the critical angle for this question. Yeah, let me see first. So we have to check for critical angle. Right? Check critical angle. Okay, how would you check for the critical angle here?
And air over and then. Yeah, actually it changed now. But then my air was like less than.
Yeah.
You know what? I'll just do n equals to v over c first, right? I'll just check the based on the v over c. That means the speed of the wave in the fast no wait, c over v. Sorry, right? Refractive index is c over v, right? Yeah, c over v. So I'll check for the refractive index first, and then I'll check for c equals to sine inverse of 1 over n.
I'm confused. Wait, this.
Yeah, the one's is small c, one's big C, right? Yeah. Okay. Anyway, so let's try this. Wait, which angle will be bigger? This angle will be bigger, right? If it does go in.
So denser to less dense.
Yeah. So this one's like denser to less dense, right?
So 40 over 1500. And the answer is like 0.
Shouldn't I do 1500 over 340 then?
But aren't you calculating from slower?
No. I always deal with faster over slower. What?
Sorry.
Yeah. Yeah. Sine I over sine R is not incidence over refractor, right? Sine I over sine R is bigger over smaller, right? Then refractive index is always bigger over smaller. So if I see 1005 over 340, I'll just take 1005 over 340, right? And then what's the refractive index for this one? What's that? How much is this?
4.411.
4.411. Then I will do sine C equals to 1 over n. I'll find the critical angle from based on this. So sine inverse of 1 over 4.411. What do I get?
13.1.
Is that what?
13.1.
13.1 degrees. Then no. Right? Because the angle of incidence is 30, right? That's bigger than 13.1. So it won't, yeah. It will not enter, it will TIR.
Wait,
Yes.
if I use sine theta over capital Y equals to V2 over V1, then I will not.
Because you don't know what's the theta 2.
Theta 2 is 90, what?
That means you want to check for critical angle, is it? Okay, Ken. You want to check for critical angle. That means your sine again one more time, sine theta 2 over sine theta 1 equals to V2 over V1. Right? That's the way the equation say, right? Okay. So which medium will be the 2? Which medium will be the 1?
Wait, so
Doesn't matter. You just choose one. You want your air to be 2 or air to be 1? You want air to be 2. Okay. Then if there's critical angle, where is the critical angle at? No, in the air. It's always in the slower medium. Because it's sound wave. So if you take 2 as the air, right? Then there's a slower medium. So it becomes sine C over sine 90 equals to 340 over 1500.
it's what angles was. But then I thought the angle of incidence will be in the air. Because the wave is coming from the air to the water.
Are you basing it on medium or are you basing it on speed?
I'm seeing on how the wave enters the boundary.
So you're basing on medium. Because you think that the critical angle must always be in the medium, not in the air. Okay. Then no.
Oh,
Yeah.
like,
So it's based on speed.
oh,
What's the definition of critical angle? Angle of incidence in a optically less dense medium, for which the angle in the optically denser medium is 90 degrees, right? Sorry, optically in the denser medium, optically denser medium, right? For which the angle in the optically less dense medium is 90 degrees, right? That means the angle of incidence is the critical angle is the angle of incidence in the slower medium, for which the angle of refraction in the faster medium is 90 degrees. So this is slower, this is faster. Yeah, yeah.
The then critical angle is the faster or slower.
They are the same. They are the same picture. This one is the same. Yeah. These two are the same. So it's either you use your understanding from secondary school, or you use your Snell's law here.
So in an optically denser medium, the wave travels faster. Not in slower.
No, this is sound wave. So this is nothing to do with optical density, because optical density is light, optical. So this is a sound wave. So sound wave in air is slower, sound wave in water is faster. Yeah. Okay. Okay. Question 4? 4A? Yeah? 4A, right? Okay. Huh? Yeah. Entire 4. Then like that everyone can do the question already, right? Then how I differentiate the sevens? No, but this is rigid rod circular motion. Wait, you all never encountered any rigid rod questions before?
No, this is the first one. So take the whole thing.
Okay, so do you want to ask me for rigid rod
Yes.
videos? Yeah. Then send me a message. Yeah.
So I text.
Yeah, rigid rod. Yeah. Then I tell you that since you totally kosong on this question, right? You watch finish already, then you try the question again. Yeah, that's how it works. I can go through it now. But then I'll be spending the lesson time going through this. When you can get this offline in a video. You know what's the point of my videos? Yeah lah, should be Should be. And the whole question is only A and B only what? Yeah. Yeah. Next one.
What up?
The rest okay already, yeah? Yeah, the rest is easy.
But I just want to check like what I wrote is right.
Uh-huh.
Yeah, so
Wait, what do you write? Are you supposed to write anything?
yes.
Oh,
Yeah.
you're supposed to show calculations.
Huh? Sure. Isn't that right? By reference to the momentum.
That means you only write everything in your answer is prose. There's no formulas or equations.
Yeah, I'm looking is the
Oh man, I would show the equations.
wait, let me check.
I will show the equations. I'll show did the answer key show the equations? It should be, right? Or what? They just describe only. This one 6B part 2. Okay, never mind. Tell me what you wrote.
Oh wait. Okay, I'm ready.
Okay, can.
Yeah, wait, he just wrote.
Just wrote Okay, can. I mean, I'll show the equations.
Wait, it gives the alternative one is equation, alternative two is right.
I will write the equation.
Oh no, actually no, actually alternative one is they write out everything right.
No, I'm telling you that I will write the equation.
Yeah.
I mean, I don't care what the marks team says, because the marks teams you only know until only next year only, right? When the papers are leaked.
Yeah, you're right.
Yeah, you wouldn't know, right? So the question is, what do you do? Right, on the exam day itself, I will write equations. But why would I write equations though? Because I say momentum. You say momentum, then I show momentum. But I'm guessing your answer is the same as my answer. Both the alpha particle and the lead nucleus have the same amount of momentum, but in different directions. Did you write that?
I said they will move in opposite directions such that the momentums are equal and opposite.
Yes, that's right. That's absolutely right. That's like 1 mark.
Then I wrote P equals to mv, then it's a very large matter. Then I wrote Ke equals to half mv squared.
Whoa. Okay, yeah.
Ke of the alpha particle is much greater than
Ke of the alpha particle is much greater than, yeah, okay, sure.
So
Yeah.
and then
You can write. But like, do you know how much? What happens if they ask you? Can you tell me how much is it? What's the ratio? Do you know what's the ratio? Can you find out?
Take off the rest, so yes.
Okay, can then okay. Yeah, your answer is sound. It's okay, right? So if you use equation or if you write it down, it's fine, right? But I would just go with equations here, right? And as in I would just go and find the actual ratio. The actual ratio is what 50 something. I did it yesterday. Yeah. Okay, good. Yes. Yeah. What's okay? Your question, Yasmin.
How KE equals something is the V must be like constant, right? Not the object will be accelerating.
No, it can be accelerating, huh?
Then what's speed you think?
The instantaneous speed, right? Depends on what you want to find. There's no such, if the object is accelerating, that means the Ke is increasing. So if you want me to find Ke at a certain point, then you must give me the Ke at a certain point. I cannot find an average Ke for or accelerating object. I can only find instantaneous Ke at certain points.
Then for the first question, right?
For the first question,
Like I don't like why do you use 9? Is it plus
This is the maximum KE.
which question are you talking about?
the one part, 1C part, 1C part 1.
All the way back to 1C.
That's how I wanted to ask you this
1C part 1. And then?
Then the final C is 9. Then I guess is 9 the instantaneous velocity.
Yes. Well, actually, it looks more like the final velocity, right? Yeah, lah. Yeah, it's the final velocity. Yeah, final velocity. Paris, your question? 6 what?
B part 3.
6b part 3. 6b part 3. Okay, what is your question really?
How to write it nicely? I don't know how to write it.
They have the same wavelength,
Okay, yes.
so they have the same energy. So all the gamma decay processes involve what? The same energy difference, right?
Again, what's that?
Huh? They have the same wavelength.
Huh?
So all the gamma photons have the same energy. No, as in like I'm just reading off what we know, right? So they have the same energy, and therefore during a nuclear decay, the nuclear energy levels decrease by the same amount. I feel like I'm ChatGPT, you know. I'm just prompting you the words. Like you know those predictive texts. You're trying to text something, then I'm just prompting the words for you. Huh? Yeah, I know, but why am I doing it for you? I'm prompting every word. That's it. Yeah, that's it. Just talk about amount. That's it. Why does the answer key say something else different? Oh, same wavelength, same energies decrease by the same amount during decay. Yeah, lor. Yeah. Same. Just keep on saying same. Then what's the question next? What? Oh, 8 ah. Now I jump to 8 ah.
Yes.
Jump to 8 ah. I jump to 8 ah. Jump to 8 ah. 8 ah.
Yes.
8 A ah. Okay.
Wait, I forget put X.
You tell me what you put for what.
Wait, yeah, but
No, the question is how do you work it out? You don't know. Okay. What is up with the? Oh, okay. You're funny, you know. You. Hey. No, you know why not? Because I'm just repeating whatever I said for the last few weeks. Replace this word.
voltage.
So which one has a larger voltage? No. So think about it. Think about it. Which side has a larger voltage? You don't know? Okay. So what are these lines? Sorry, what are these lines? What are these lines? What's that? Field lines. So field lines point from where to where?
Positive to negative.
Then that's your answer lah. No, but that's the thing. That's the thing. Cannot.
Oh, I'm right.
Yeah, you're right.
You scared me.
I'm not scaring you. No, but then why don't you make the link that because it's positive, so it has larger voltage? So this side here is plus, this side here minus.
Oh.
Just say that E field lines point from higher voltage to lower voltage, and replace the word voltage with electric potential. Therefore, Y is higher voltage. I mean, 1 mark for saying why Y is higher, and 1 mark for saying where the E field lines point from. The E field lines point from higher potential to lower potential.
Okay.
Yeah.
Amazing. Thank you, sir.
Okay.
Wait, does the distance matter?
No, it doesn't matter. I mean, the distance matter for the E field strength, but they're not asking for E field strength. They're asking for voltage. They're asking for voltage. So this is your overthinking it, right? Voltage. Wait, next one. You what's that? 8B part 2. 8B part 2. Determine energy to launch a satellite. Where do you want to launch it to? Huh? You
They just said
you want to launch it to here what?
Oh.
No man? Wait, I don't understand.
I was like, wanted to infinity.
If you launch it to infinity, that's not a satellite. That's not orbital satellite. If you launch it to infinity, you're losing the fella. I'm trying hard to understand what you're confused by. Because now that I point out all these things to you, you know how to calculate it. That's like, I'm not even working with you on the calculation. I'm working with you how to read the question.
All of the
So wait, hang on. So the amount of KE that you need,
Yes.
okay, no matter what, the amount of KE that you need to launch from the surface to that height,
Yes.
okay? Then the KE required is how much?
You okay?
Yes. GM. M over R. Am I wrong?
That's when it's already orbiting.
Yes.
I'm trying to launch this rocket from the surface to the height that is required. The half GMM over R is when it's orbiting, and that's the KE when it's orbiting. That's KE orbit.
Also, you have to consider the radius of
No, as in, so what do you need to consider? What are we trying to do here? Really,
the launch.
the rocket, is it orbiting already?
No.
Not yet, right? So you cannot use half GMM over R, right? So how much KE do you need to launch a rocket from the surface to that height? What do you need to sacrifice the KE to gain? What potential energy? What GPE, right? GPE, okay. Okay, I write this down for you, GPE final minus GPE initial.
Yes.
Do I still need to? Why not?
I can do it.
What's the equation?
Um,
Negative GMM over R plus H minus go. GMM over R.
Thank you.
Can okay, can.
Is that
Ah,
the KE plus change?
that's when it's in orbit.
I just
KE, why? And the answer is literally energy minus KE plus delta.
KE plus delta PE.
Yeah, this is delta PE.
Yeah, no, the answer.
Yeah, I'm showing you that this is delta PE. I put it at the amount of KE I need is equal to the final PE minus initial PE.
So when you determine
Yes.
Energy is equal to KE plus delta PE.
Yes. Because it's
Equals to what?
KE
Uh-huh.
plus delta PE.
So the energy is what? Ke. Okay, hang on. Let me see. Oh,
Wait, that only looks so weird.
but they give you the KD on top.
Where?
Bro, I don't understand the point. Like,
so this one here,
whatever.
this one here, you have to add on to the original
That's why
KE. That doesn't make any sense.
sticks. They give
No, no, that doesn't make any sense. So you're supposed to add on to this KE.
That's how you
Huh. That's a bit surprising. That means after so this is just to help you find the launch KE, is it? Then for the final answer, you still need to add the launch KE plus the orbit KE. Wow. Okay, I didn't know that. It's very strange though.
Yes. That's
Yeah, because if you ask me what's the minimum energy to launch a satellite,
But it has KE during orbit, so maybe they
yeah, maybe they want the additional KE. I don't know. I would have just calculated this because if you want me to launch it to that height, then this is my launch KE. But if you want me to add on to the orbit the KE, I wouldn't have known that you wanted me to do that. Yeah.
But it's so sad. Like, minimum launch energy is only KE, but if they want you to find like
If they want you to, okay, I didn't see the first part at first. So now they want you to add on to the KE of the orbit, is it?
yeah.
Okay. This one, I would have lost the mark here. Yeah, I would have calculated this first part here, and I didn't realize that they wanted me to calculate adding on to the orbit KE. Yeah. I mean, that's the way I interpret the question, right? Down here. Right? I didn't see the first part. If I saw the first part, then maybe I realized that, okay, together with the orbit KE, yeah. Okay? I'm not going to tell you that, oh, yeah, this question, you should look at it and then you should understand that launch plus orbit. I won't. Because I myself would have read it as launch KE only, without the orbit KE. Right? So the amount that you want me to launch, yeah, to that height. Yeah. But because then determine the minimum energy required to launch a satellite, including its orbital KE, then okay lah, then I'll just add on to that lah. Otherwise, I wouldn't have added on. Right, what's the next one?
9A, 9B, but yeah, 9.
9B part 2. Determine work required to increase the separation of the plates. Did you calculate the energy before and after?
I thought this answer.
Huh?
I don't know after.
Don't know how to find the after.
If you change the
So
capacitance, right, then you see that.
wait, did you calculate the energy stored in the capacitor here?
Yeah.
How is that calculated?
Oh, half
Half CV squared, and the C is what? EA over D, is it?
yeah.
And V squared, is it?
They never give you E. They give you the
Oh, they give you the capacitance already. I see. Okay. So EA over D is 1.5 times 10 power minus 10, is it? Okay. So then what happens if I increase the place distance to 4 mm? Because right now is 1 mm, right? So what happens to the C in when it's increased to 4 mm? Yeah, so divide by 4 lah. 1.5 times 10 power minus 10 divide by 4, right? Then what do you get? Then what's the second energy? Half C2 V squared, right? Does the V change? No, it doesn't change. What does it change? Sorry. So it changes. Yes, it changes. So the V will change, right? But the Q doesn't change. The amount of charge doesn't change, right? So what's the other equation for? I mean, if you want to make your life easier, what's the other equation for energy stored in a capacitor? Half Q V. So you have to calculate the new V lah, right? Okay. Yes.
So shouldn't it be a one step? It's right though.
Like the answer is actually one step.
Yeah, but I don't understand they are one step.
I don't also understand the one step answer. I know that if you ask me to find the work done to increase the separation of the plate, right? I will find the energy first, I'll find the energy later. They asked me to find the energy first already, right? Down here. Then I'll find the energy later, and then I'll just find the difference. I don't know about QW though. What? Does it work? I It's a bit too complicated to calculate Q. Hang on. No, it's not. It's just the normal amount of charge, right? It's the same amount of charge. So no matter what you do, it's either you find half QV, that means you have to find the original amount of charge, right? The charge doesn't change because you disconnected it. I don't think QW will do it though, because that's for moving a electric charge, right? That's for moving electric charge between a field, a constant field. So yeah, so I don't think you can do this here. Yeah, yeah. What Q would you use? Oh, the charge of plates. No lah, no lah. The charge is not being moved. No, no, I'm talking to Dylan. Yeah. Sorry, what? No, this is them doing the shortcut. We don't do shortcuts. We just work out what we need to work out. Yeah. So find the final energy, find the initial energy, and then find the difference. Like, I'll just leave the answer as that. I mean, if you want the shortcut, that means you need to know how to manipulate it. Also, E2 equals to half C2V squared, right? So C2 is what? C2 is C divided by 4, right? Then V is what? V equals to Q over C, is it? Right? V equals to Q over C. So the amount of charge still stays the same, but the C has now divided by 4, right? So C divided by 4, is it? Then need to square this. Is it? Something like that? Something like that, then something like this, then something like that. I don't know. Then you find the difference. Then you need to do the E2 minus E1.
In this part one, we already found that capacitors increase by factor of 4 and V increases by factor of 4. Then the change is...
Yeah, but you need to E2 minus E1 though. Yeah. So you have to use, no matter what, you still have to find E2 minus E1. So it's the same thing. Same thing. What's the next one?
K, 9D.
What's that?
9D.
9D.
I don't know how to.
Diode bridge rectification circuit modified by adding a capacitor in parallel with the output load. Describe a reason for this modification. So they're asking you why you put a capacitor in parallel to the load. Okay. Wait, have you not seen this before? Never seen this before? Okay, hang on. And I just jog your memory a bit.
Okay, I watch his videos to see.
This one. Capacitor rectification circuit in parallel to the load.
So it's smooth.
Yeah, for smoothing. Yeah, for smoothing.
The answer is
What does the answer say?
without a capacitor, output voltage or current drops to 0. Capacitor provides smoothing. Voltage or current output becomes constant.
Fairly constant, relatively constant. Yeah.
That's if I write those two enough, right?
Yeah.
Capacitor provides smoothing, then becomes fairly constant.
Yeah, you can say that the capacitor is charged by the source and it discharges to the load, right? But that's all inside the video. Yeah, that's all inside. So if you need the capacitor one, you better ask me for it. I was actually hoping to do the last half hour to cover more like other business, like I did extra revision for like the other class as well, because yesterday I did the circular track, bank track. I did some capacitors as well. So obviously I didn't. So I have to send you all the videos for that. Because I was doing a question where I had a bank track and a motorcycle with friction, right? So additional friction. But I sent it out I sent that out as a screenshot. I think I can't remember. But yesterday's recording was I don't know, something wrong, something went wrong with the recording yesterday. Yeah. So nope, I don't have it, and I don't have time to go through all the extra stuff. Right? But okay, what other questions you have here? Why is it a glue-on, right? Yeah lah, but why is it a glue-on?
Because it's
Because the question says so. Yeah, because we always, I mean, I say that, you know, during our lessons, right? During our lessons, we always say that a quark decay is due to what? A quark decay is due to weak interaction force, right? Right here, right now, they're showing you that the quark is decaying due to a gluon, right? So I mean, as of yesterday's one also is like, why is it like that? I think the conclusion is because it's like this. Because it's like that, lor, right? I mean, prior to this 2022, I think no one in the world would have expected this kind of Feynman diagram to come out. So the question is, how fast can we adapt to this, right? Yeah, but your fundamentals should all be there, because that's what the next question is all about. How do you show there's a quark anti-quark pair for 3 marks? How do you show that particle X is a quark anti-quark pair for 3 marks? And which conservation law are you talking about? Charge. Good. Which charge are you talking like? So what's up with the charge? What's the charge of X? So the charge of X must be -1, right? Because this is -1 and this is 0, right? So the charge of X must be -1. And since it's only made up of 2 quarks, what must be the charge of each quark? -1/3 and -2/3, right? Which tells you that one of the quarks is a quark and the other one is a anti-quark. That's the reason why. But which one specifically, we don't know, right? But we know that up chum top is 2/3, right? So it's either anti-up or anti-chum or anti-top, right? And the -1/3 is either a downstrange or bottom. Which one? You don't know. No idea. Nobody knows, right? I don't know. I got the 3 marks. I'll move on, right? This one, no need, right? Okay, can. Okay, I still got about 6 more minutes. I have to decide now. Very big decision. What do I want to do? Do I want to do capacitor discharge or not? Wait, now let me think first, huh? I think the capacitor discharge one, you can just easily catch it from the original lessons, because over the couple of weeks, the reason why I came out with this few, oh no,
oh, bro.
yeah, just be careful.
Sorry.
Yeah. Um, turn on already? Turn on already, huh? Okay. So the reason why I chose circular track, bank track, capacitor, and Doppler is because these were some of the more problematic questions that you know I've gotten, you know, from the rest of them, from people around asking me questions, right? Circular track, bank track, capacitor, and Doppler. I think capacitor. I think capacitor. I can leave you to the.
Wait, it's show have a direct indication.
You're asking me to do something that I can show you a video for.
Oh, okay, yes.
So you have to ask me for the video. Yeah, because if you know that there's something that is bugging you, then you should ask me whether I have a video for that. If I don't have a video for that, then I'll go through in class. Okay? Yeah, wait, I'm waiting for the projector to turn on. Yeah, I know. So I will not touch on capacitor today. Okay? But I just want you to remember the one thing, okay? So when you have a capacitor discharged to another capacitor, sometimes they give you a resistor in the middle here like this. Okay? Right? Do you have to be concerned about the resistor? Why? Take out what? It doesn't store the charge, you know. The charge will pass through it, right? So there'll be energy lost through the resistor. There'll be energy lost through the resistor, but the final voltage is not affected by the resistor. Right? So it's kind of like this. Right? I don't know why yesterday's video didn't record. If I give you a circuit like that, okay? and the battery here is 12 volts. What's the final voltage of the capacitor over there? It has to be 12. So does the resistor affect it? No, it doesn't. The final voltage of the capacitor is still going to be 12 because it will increase until it's 12. Then it will stop charging.
But it's
If at any point in time, right, it is still lower. Let's say for example, it's like still 8 volts here like this. Does current still flow? Is there still a potential difference?
Yeah.
Does current still flow? Does it continue to charge? Let's say it continues to charge, right? It has to still charge, right? So it has to still charge. Yes, I know current is flowing through the resistor. Yes, I know it's taking up some voltage, right? But then there's still a potential difference. It's still charging, and then it goes to what volts? 9 volts. Then it goes to what volts? 10. Then it goes to what? 11. Then it goes to 12. So it only stops charging when it's 12, right? It only stops charging when it's 12. So what's the point of having a resistor? Yeah, it slows down the charging process, right? To prevent overheating and all that. Good, right? So all these things, I don't know, I can't remember whether I covered it in the normal lessons. I have. Okay, so it's all in the videos. So then the next thing is this, right? What's the okay? What's the effect? What's the effect of the resistor when I plot a I versus T during the charging process? Yeah, it's tau lah, right? So it becomes the charging becomes something like this, right? So depending on how high the resistor is, it will affect how long the charging process is. What happens if I replace the resistor with a much higher resistance? Like a super high resistance, how would the graph look like then? Right? So with a much higher resistance, you will have a much lower current, right? But then it will stretch out longer.
one current.
Current is low because now you have, like, let's say for example 10 ohms versus 1000 ohms, right? The initial current will be much lesser, right? But then with the 1000 ohms, it will stretch out longer. So what happens in the area here? It's the same area as the blue one. Right? It's the same area as the blue one. Understand this? Okay. Then what happens when you are like, so then the question was, the next thing I did for them was this, right? The next thing was I switched the thing over to another capacitor here like this, right? So the thing is, this part here you can get it from the lessons itself, right? The original lessons, right? This capacitor is charging the uncharged one, right? When I switch the switch over like this, I flip the switch over. So when does it stop charging? When the voltage is the same. When the voltage is the same. So if you know that you are severely, like, still lacking this, you better go and go and revise this. You cannot use this 1.5 hour, these 2 hours here, right, every week, and then just expect for me to go through everything, right? That's what my videos are for, right? Your offline revision, right? Someone to explain stuff for you when I'm not around, right? So you have to ask for that one. How does a capacitor discharge to another capacitor, right?
So if there's no resistor, then you just overheat and then it will
I mean, that's the worst case scenario, overheat lah, right? But if the amount of capacitance is small, it doesn't really matter. So the current just quickly swings, like, just goes over like this, and then both capacitors will be charged to the same final voltage, right? So the resistance job is just to slow it down. Okay. I have to do the bank track and the horizontal track on another lesson. I probably have to do it tomorrow or something like that. It means tomorrow's lesson will be probably 3.5 hours.
This she won. I won. Full stop.
She win what?
132.
Oh, is it 132? Yeah lah.
So she's still on.
No, she's not.
Yeah, how she know? Yeah, how she know, bro?
Maybe she's what? Yeah, maybe. Yeah, I don't know. Maybe. I also don't know actually. I don't know how she knows.
Yeah, I read it. I won.
Because they expect you to have message her lah. Yeah. What? Am I? No. I think maybe I accidentally put it on public then. I should switch it back to unlisted. Is it?
Yeah, I was like watching your videos, like, oh, what's he like?
Oh
You know,
damn.
impressed.
Okay. I have to switch it. I think I accidentally messed around with the circuit. With the settings. Okay. I'll tell you what, I'll do the bang circle and the horizontal circle on tomorrow's class. Right? So I mean you have to attend the tandem anyway, so you just get ready to have a long lesson now. Okay? Right. So what I'm doing is I'm covering things that are not covered in my original lessons. Right? I'm covering things that I've not covered before in my original lessons. So I need to do a Doppler one as well. Okay? I need to do a Doppler one. Right? Yeah. I'll just let you know because I need to sort out the sound Doppler and EM Doppler. But I did send out a very long text on the sound Doppler and EM Doppler. So if you go and search the message, you should be able to see everything I've written there in my notes there. Okay?
So tomorrow you're gonna 3 hour lesson and you're going to meeting.
Is it? Oh yeah. Shit. Okay, can. Right. I have to see first. No, that's fine. Okay? These some things don't matter to me. Until I start feeling pain. Alright, go. Right, go and meet Narella. Yeah, the rest of you online.